Today I'm going to talk some more about the rotating Earth as we have come to understand it, and as it is taught in school, and hopefully clear up a few misconceptions surrounding it. What is the Coriolis Effect? Most people think of the Coriolis Effect in terms of meteorology, with the rotating Earth moving under the atmosphere. For all intents and purposes, the atmosphere is considered stationary with respect to the Earth rotating under it. Of course, there are high and low pressure systems within the atmosphere that create winds and various other localized weather conditions. And we are taught that the rotation of the Earth is the root cause for the direction of the spiraling winds. For example, large weather patterns such as hurricanes rotate in opposite directions in the northern and southern hemispheres. This is all due to friction at the surface, where the dirt meets the air above it. We are told that the ground effects on a micro level are so minuscule that we don't feel its immediate effects locally, but on a macro scale, over vast distances, the friction between the stationary atmosphere and the dirt surface is said to be the root cause of the spiral wind directions in the two hemispheres. One common misconception I often hear is that the atmosphere is somehow tattooed to the rotating Earth and they move as one unit, so to speak. This statement could be perceived as true, likely because it reflects what we observe in our natural world. We don't perceive any motion whatsoever, not even the slightest consistent microbreeze from the east as we rotate under the atmosphere. Now, anyone that gives this a moment's thought will soon realize that in order for there to be any friction at all between the atmosphere and the surface, there must first be a difference in speed and a point of contact. It's Physics 101. And according to the bare-bone fundamental premise of meteorology, of how a rotating Earth must interact on a physical level with the atmosphere above it, we can safely assume that the tattooed rotating system is not a valid statement and simply a rumor and a misconception. There would be no need to teach Coriolis in the physical Earth sciences because there would be no detachment between the Earth and the atmosphere, resulting in no cause for friction and ultimately no Coriolis. Another way to confirm this misconception to be a misconception is to review what we were taught as children about the Coriolis effect and objects that are detached from the surface and moving freely over the Earth. The best way to do this is to go straight to the source, the Teacher's Guide to Teaching Coriolis, Because the Earth Turns. Brought to you by none other than the Meteorological Society of America. And supported by the National Science Foundation. Now, everything we need to know is right here on the first page. First, it talks about ocean effects and then goes on to say, objects, including planes and boats, freely moving horizontally almost everywhere on Earth, except at the equator, turn right or left. The turning of the moving object's path, as seen from our vantage point on Earth, is the Coriolis effect. You have no idea how hard it is to keep my opinions in check at this moment, but I digress. Moving on. Why does this curved motion occur? Aren't objects that are moving freely and unconstrained in horizontal direction supposed to move in a straight path? As described by Sir Isaac Newton's first law of motion, an object in motion should remain in motion in a straight line unless acted upon by an outside force. Blah, blah, blah. If there is no horizontal force acting on the object to make this happen, there must be another explanation. There is. The Earth is turning underneath the moving object. That is, the Earth rotates. All motion must be measured with respect to something, and the Earth is our frame of reference. Earth is so immense that we usually think of it as stationary. That's probably because it is. That is why objects moving horizontally and freely appear to turn to the right or left. Actually, it's the Earth that is doing the turning as the object moves forward. Now, there is only one definition for unconstrained, and only one way to interpret free moving. So the object that is now detached from the rotating surface is indeed free to move in any direction, according to Newton's first law. And by being detached from the rotating surface, it becomes bound to the same atmosphere that science claims is the root cause of Coriolis due to friction where the dirt meets the air. So you can clearly see, the atmosphere being tattooed to the rotating Earth is a simple misconception due to a simple misunderstanding of the very root of Coriolis. Now, this is not uncommon, or surprising really. The rotating Earth with regards to freely moving objects such as plane, helicopters, and even baseballs is taught at a very young age. Simple enough to remember that the Earth rotates, but boring enough to forget the details. So, now that we are all on the same page, I have a question for all the science guys out there with the university educations and the master's degrees. Hell, this one's even for the professors that are teaching this stuff. If an object becomes detached from the surface and is now considered unrestrained and able to move freely in any direction, as we are led to believe in this case, and as we are taught specifically, then why, if I am hovering in a helicopter, does the Earth not rotate and the West come to me? This is a very simple question that I would expect has a very simple answer, but there seems to be no logical answer to this question, at least not from the scientific community, to the best of my knowledge. I have posed this question in the form of a cannon being fired straight up and occasionally landing back into the barrel it was fired from, and the only answer I have come across that is even remotely on the cusp of making sense is the argument that maybe inertia, relative motion, or horizontal velocity plays a role in this. Regardless of the title they choose, they often post a link to this video or various other animations showing the same type of thing. They will use this as the reason why a cannonball can sometimes land back in the barrel. This is the same excuse used for a hovering helicopter, as the helicopter is believed to maintain the angular velocity of the Earth before it leaves the ground and is considered detached. All of the arguments fail to work in sync with the principal scientific foundation of the Coriolis Effect as taught in our education system. The Earth rotates under the atmosphere and anything in that atmosphere, such as planes, helicopters, and even baseballs. Even if we assumed that the horizontal velocity of the helicopter retains its eastward momentum after liftoff, how long will it take your imagination to allow you to consider that helicopter to be officially detached from the Earth? You know, to the point where it can move unconstrained and freely, just like it's taught in grade school? Now, most people just throw equations at me at this point, and say I don't understand the Coriolis. Well, I firmly disagree. I understand it quite well, and I have read through tons of literature on the subject. Now, aside from the mindless onslaught of people parroting textbooks examples of formulas and equations that fit the globe model, not realizing for a second that they are given both the model and the formulas to work with, and told how and what to calculate using only the tools provided and only in the context provided, aside from attempting conversation with mindless zombies in search for a simple answer to a simple question about a helicopter hovering over a rotating Earth, there are still only two arguments, and they are both absolutely ridiculous. So, that being said, the question still remains. If, and in this case, when, an object becomes detached from the surface and is now unconstrained and able to move freely in any direction, as we are all led to believe in this case, and as we are all taught specifically, then why, if I am hovering in a helicopter, does the Earth not rotate and the West come to me? It's a very simple and logical question that should have a very simple and logical answer. Yet there is no logical, factual, or reality-based answer provided by any university anywhere in the world that I can find. But maybe, just maybe, there is one logical answer. One that is so simple, most people wouldn't believe it if their life depended on it.
If Earth were spinning, wouldn't there be an actual Coriolis effect on airplane flights, north and south? How much does the speed of rotation change in, say, 10 degrees? Would a pilot have to factor Earth rotation into his navigation? Let's review the spinning globe claim. Earth is 24,901 miles at the equator. If it rotates once each 24 hours, then the speed is 1,038 miles per hour at the equator, or 0 degrees latitude. However, in that case, at 31 degrees north, the speed is 890 miles per hour, and at 41 degrees north, the speed is 775 miles per hour. That means the difference in speed between 41 degrees north and 31 degrees north is 115 miles per hour. Let's take a virtual flight and see what would happen. We will fly from South Bend, Indiana at 41.67 degrees north to Mobile, Alabama at 30.96 degrees north. Our airplane will be a Cessna 182 Skyline. It flies at 145 knots or 167 miles per hour and carries 4 people. South Bend to Mobile is 770 miles. At 167 miles per hour, it will take about 4.5 hours. Our heading to Mobile is 189 degrees. How does a pilot maintain the 189-degree track? What about a crosswind blowing the plane off course? The most basic method is called pilotage. There are large and very detailed charts called sectional charts, which have symbols depicting airports, towns, roads, railroads, rivers, towers, and golf courses, because all these can be easily seen from the air. A pilot can look at these charts and see his departure airport and all places along the route of flight. So long as he passes over those locations, he will arrive at the destination. So here's our skyline, about 12 miles on course to Mobile. On our left, in the green circle, we see a maroon flag. That is a golf course. On the right is another golf course. So we know we're on track. If there is a crosswind, the pilot can turn into that wind a little and maintain the same heading track. For a flight from South Bend to Mobile, Alabama, the ground track is 189 degrees, always. Nowadays, the data of our charts can be combined with position location of your airplane, and the pilot can easily stay on course and see exactly where to fly in order to stay on the correct ground track. This navigation information is provided by radio signals from ground-based towers and displayed data to allow the pilot to remain or return to the correct ground track. But in all cases, the ground track to the destination never changes during the flight. The truth is, if our flight starts on a 189-degree track and stays close to that track, after about 4.5 hours, the navigation display will look like this. Our flight will be on final for Mobile, Alabama Regional Airport. Our skyline will touch down with no problem at all, and no pilot and no navigation equipment made any compensation for the spin of the Earth. Now, if the Earth spins, then these are the actual speeds. South Bend would be moving east at 775 miles per hour. And since we feel nothing, that means our skyline is moving east at 775 miles per hour also. But Mobile would be moving east at 890 miles per hour. This is the globe theory. That means Mobile would be moving 115 miles east of our flight path each hour. If Earth was spinning, then our flight would be 517 miles northwest of Mobile and 70 miles northeast of Dallas, Texas. But that never happens because the Earth is not moving and air travel proves it. Thank you.
Rising.
So let's get straight to the point. Let's talk about Coriolis.
Okay.
If I'm on the merry-go-round that spins once and I throw a ball, it deviates, right?
Mm-hmm.
How come that doesn't happen on the Earth?
Why do you think it doesn't?
But wait, when I'm at the equator, does the ball fly sideways when I throw it?
Depends on which way you throw it. Yeah.
If I throw it north, will it fly sideways 460 meters in 1 second?
Okay. On the equator itself?
Yeah. If I face north on the equator and I throw a ball in front of me,
Yep.
does it fly sideways at 460 meters for every second?
Why would it fly that fast? It curves to the right, but when you're throwing
How
a ball,
fast
you're
does
not
the
talking
Earth
curve.
rotate in 1 second in your model of the equator?
Oh, it's 1 degree a day, or excuse me, it's 1 rotation a day.
And how
About
much
15 degrees an hour.
how much miles per hour does it spin in an hour?
It depends on your latitude. The linear
equator.
speed at the equator would be about 1,038 miles an hour.
That's 460 meters a second. Did you know that?
Okay. So
So if I throw a ball at the equator north, does it fly sideways 460 meters like it does in the merry-go-round?
no, of course not.
Why
Nor
not?
does it do it on a merry-go-round.
Yes, it does. It deviates off a merry-go-round. Of course it does.
It deviates. It doesn't stop.
Deviates.
It doesn't lose all of its inertia as soon as you immediately let
So
it go.
does the ball deviate at the equator?
Yes, it would.
Really? I can throw a ball in front of me and it's going to deviate sideways.
It curves to the right. Yes.
Are you joking?
No.
How much does it deviate?
Oh, tiny, tiny, tiny little
Why is it a
amount.
tiny bit when the Earth is moved 460 meters in 1 second? What if I
Well,
throw it for
first of
3
all, the
seconds? in
ball
the air?
when it's in your hand, the ball when it's in your hand is already moving at that speed, and the deviation would be the difference between the speed of the equator and the speed of wherever the ball ended up over the time it takes for
So
the
if
ball
we
to get there.
see if we hover a helicopter, how come the helicopter doesn't deviate?
Why would it?
Sideways.
It's under control and it's over a specific spot on the earth.
If we hover a drone over a spinning merry-go-round, the merry-go-round moves underneath the drone, right?
Okay, but the drone is not got the inertia of the merry-go-round.
Why not?
So it didn't start off with the inertia.
does,
it didn't
the
start off
helicopter
moving,
does the
and it
helicopter
doesn't-
does the helicopter have the inertia of the ground?
Yes, of course.
Really? So
Yeah, of
if I fly a plane and land on the north to south runway, I'm going to chase the runway sideways.
Why would you do that? Why do you think that
planes
occurs?
don't
You're
account for
already
rotation.
You're already going at the same rotational speed of the Earth at that point. So your speed relative to the runway is 0.
Right. So in other words, the Earth can be treated as stationary, right?
No,
Why
the
not?
Earth is not stationary.
How do you know that?
If you look at the relationship or the relative speed of the surface of the Earth and the surface of the plane, they're the same.
Yeah. So if I fly a plane against the rotation of the Earth, sorry, and we
Yeah, what
set the
about
plane speed, we set the plane speed to be 500 miles per hour.
That's over the ground. Yes.
Yeah. Does it move? Does it get pulled back 1,000 miles per hour now?
Why on earth would it do that? It's already going.
You're
along
saying the
speed of
hovering
the ground.
helicopter tags along with the atmosphere.
The atmosphere tags along with the surface, and the helicopter's with it. It also has the
Right,
initial.
so how come the
question.
helicopter goes sideways with the Earth perfectly, so it just looks stationary because it's tagging along with the atmosphere, right?
Correct.
So you said it as if it goes higher in altitude, it still tags along the same, right? Does it still appear stationary
much,
to
yep.
us?
Yep.
What causes? But at a greater height, you'd agree that's a greater radius.
Yes.
So what causes the atmosphere to magically just tag along with the Earth like that? What force causes that?
It's called friction. And
If
it
I
doesn't
wave-
tag
if I
along.
wave-
It doesn't
hang
tag
on.
along 1-to-1. It
If I
doesn't
wave
tag
my
along.
hand
It
here,
does lag a little
if I-
bit. For
hang on,
example,
hang on.
for
You said
example,
friction.
at 100 miles above the surface, the atmosphere would lag behind about 25 miles an hour.
So if I wave my hand here, the whole room doesn't start just waving air everywhere. You agree, right?
No, the air around your hand does, though. That's why you can fan yourself.
So, but you just said friction. So how come the friction of my hand doesn't make the whole room windy?
It does move air,
But
and it's based on friction. Yes.
Why would the fan that's pointing, say, straight? Why would the air next to it start to move? It doesn't. It never will.
Well, yeah, it will, because the
side.
air that you're blowing out of the fan will cause air next to it. It's not like a tube of air coming out in isolation. It's attached to the air next to it, and as the tube of air goes out, it'll start dragging the air around it with it.
So you're saying you can set up a fan in the middle of your room? So wait, so the fan's going to start moving the air beside it, up above it, all in the room.
Yep.
Wow.
Have you ever tried it?
Yeah, it doesn't happen.
Okay, how did you try it?
For hours in the room.
How did you test it?
The whole air doesn't get windy.
So it didn't set up a circulation in the room at all.
The friction of the fan is not equal around the whole room. It doesn't equate.
Of course not. It drops off the farther away you get from it, just like the atmosphere does.
Does it?
Yep.
So it's not magic. So if we keep going up in altitude with the helicopter, it's going to deviate sideways. What you're saying?
Well, it depends on how high you go. If you go up 100 miles, you would have the appearance that it would be drifting at 25 miles an hour over the ground.
So you're saying the atmosphere is tethered to the Earth, right? In a rotation, right? How come clouds move in all directions?
What do you mean they don't move in all directions?
I've seen clouds move east. I've seen them move west. I've seen them move north.
At the same time?
I've seen them at different times. If you're saying the Earth rotates in one direction, though, right?
Yeah, but the wind moves in many different directions. The wind has to do with high and low pressure, not so much the rotation.
Exactly.
Some rotation, but mostly.
So Ranhan was wrong when he said Coriolis had to do with wind.
It does have to do with wind, yeah.
So I just want going back to the Coriolis. Okay.
Sure.
We throw a ball at the equator. It's not going to deviate sideways.
Who told you that?
Because you can literally throw a ball and it's not going to do it.
Okay. Do you think you're going to see the deviation in the range that you throw a ball? A few feet at
hang on.
speed? Do it with an artillery shell.
Yeah, hang on. Distance isn't in Coriolis formula.
No, the deviation is in Coriolis. Your ability to measure that deviation is related to distance. Yes.
So, but if I throw a bullet, if I shoot a gun north, it's not going to deviate sideways 460 meters.
Are you sure about that?
It's not going to deviate sideways 460 meters because of the rotation.
It doesn't need to deviate 468 meters. You have to have the time of flight of the bullet. So if you fire a 308 round about 1,000 miles due north, the deviation is going to be on the order of just 2 to 4 centimeters. I calculated it once. I don't have it right off the top of my head.
Do planes account for rotation of Earth?
Yes.
How much?
Well, the way a plane...
hang on. You think a plane flying is going to account for that?
Yes.
Like they might for wind, maybe, not for a spin of the Earth.
Well, the wind is going to be a much greater factor than the spin of the Earth is. But the way that you account for it, are you familiar with vector addition?
Vector addition? No.
Okay. Well, let me explain it to you then. If you look at a grid that is north, south, east, west, okay? Now, if you go straight north, all of your speed is going straight north. If you deviate a little bit to the northwest, some of your speed is going to the north and some of your speed is going to the west. Does that make sense to you?
Well, on a spinning object, yeah, okay.
Okay. No, on any object. That's just simple vector addition. It works on a flat plane too. So what happens is to maintain your course over your flight path, that little magenta line, if you're being blown or moved from left to right, you have to deviate back a little bit to the left to stay on course. That little bit of deviation, second by second, increases your speed to the west. And as a result, when you're going north, you're constantly kind of leaning a little bit towards the west to stay on course. And that little leaning accounts for the Coriolis effect, which would normally blow you up or make you move off course to the east because you were already
In other
moving.
words, so a helicopter hovering a meter above the Earth doesn't experience Coriolis, right?
No, of course not. It's not moving.
It's tethered to the Earth. It's tethered to the atmosphere.
No, it's not moving. In order to have Coriolis, you have to have
So
displacement.
the Earth doesn't rotate underneath the helicopter.
Of course not,
Why not?
because the helicopter is rotating at the same speed of the Earth. It's
As
not
the-
moving relative
what's
to the ground. Why
How's
don't
it
you understand
tethered to the
relative
Earth?
speed?
Though? How's it tethered to the Earth like that?
Well, it starts on the ground and it's moving with the Earth. As it comes
How?
up, it still has that inertia
How does it have that inertia?
because that's how inertia works. If your object, first
resistance
law of
to-
motion,
hang
an
on.
object in motion will remain in motion unless acted upon by an unbalanced force. There's no unbalanced force acting on it.
Right. So why? What? What? So
on,
inertia
you
is
can do it,
resistance
man.
to force, right?
Inertia is resistance to change, not force. Yeah, change. So an object that's in motion will remain in motion.
So if we
To
hover,
change that, you have to apply a force to it. That's where you're getting the force
so it's
from.
equally as valid for me to just say that the Earth is stationary relative to the helicopter, right?
How would the helicopter know the difference?
They wouldn't. That's my point.
Okay.
It's equally as valid for me to say that the Earth is just stationary relative to the helicopter.
It would work with a stationary Earth relative to the helicopter hovering, but that doesn't prove that the Earth is stationary. You still have
So
to do that.
So if we flew a plane with the rotation of the Earth,
Yep.
but we set the plane speed at 500 miles per hour, does it moonwalk backwards because it's going slower than the rotation?
Why would it? I told you it's relative to the surface of the Earth. So it's moving
Right.
across
So
the
it's-
surface of the Earth at 500 miles an hour. The rotation doesn't have anything to do with it.
So it's equally as valid for me to just say that the Earth is stationary then.
There are other clues that you can look for in a moving aircraft that will tell you
Like-
otherwise. The Utvos effect, for example.
The what?
The Utvos effect.
Which is?
As planes move with the rotation, objects in the plane become slightly lighter. And
Wow.
if they move against the rotation, objects become slightly heavier. And that
Okay,
is a
so-
measurable effect.
So, but in relation to the ground, it's equally as valid for me to say the Earth is stationary.
Since the object is moving relative to the ground, you can't tell if it's moving or not moving.
Right, so now if we spin the Earth, we do a 180 with the plane, right? Go against the rotation at same speed, 500
Yep.
miles per hour. Does it move faster? Because now the rotation.
What did I just say? What did I
Yeah.
just say?
Let me get my point out. So the rotation of the Earth's coming towards you now 1,000 miles per hour, but the plane still goes like the Earth is stationary, right? So then
That
it's
as soon as you
equally as
leave the
valid.
Earth, the plane suddenly stops.
And then it's
and the
equally
Earth
as
moves
valid for me to
underneath
just
it.
say the plane flies like it's
You
stationary.
can't make that connection that the plane
Yes, I
does
can.
not suddenly stop as soon as it leaves the Earth. It doesn't lose its inertia. It's still
Right, but when
moving
you're
with
flying
the
against the
rotation.
rotation, now it should be working for you.
Okay, is it changing its relative position to the surface
It's
of
on
the
the
Earth?
equator and it's flying against the rotation.
Does
now
it
the Earth is-
change its relative speed
No.
in
it's just
relation
flying-
to the
it's flying-
surface of the Earth? It
It's
does
flying
not.
500 miles per hour.
In relationship to the surface of the
Yes.
Earth, not the rotation. It doesn't have anything to do with rotation. It already has
saying,
that
I'm saying
movement
the
from
plane
rotation.
speed. I'm saying the plane speed is 500 miles per hour in the air. It's flying
And I've
that
already,
fast.
yep.
Against the rotation.
Okay.
Does the plane get to its destination faster, 1,000 miles per hour? Because now the Earth is moving towards you.
So
So
I'm
the
not
answer is
gonna-
no, right?
again,
It doesn't.
don't need to.
It's equally as valid for me to say the Earth is just stationary, the plane's just flying. Relative
Considering
to
the plane is moving relative to the surface,
yeah,
you can look at it either way. However,
Right.
there are things that you still have to demonstrate which way it is. And I've already
Yeah.
demonstrated that it's moving, it's
So
rotating.
when we land the plane on the north to south runway on the equator, where the Earth spins 460 meters in 1 second, the plane doesn't chase the runway sideways.
Doesn't need to because it's moving relative to the surface of the Earth. That's already been explained to you a number of times. Why are you not getting it?
So it's equally as valid for me to say the Earth is stationary then in that instance, right?
No, it's valid for you to say you can't tell one way or the other from that situation. There are other ways.
It's equally as valid for me to just say the plane is flying and it's landing on a stationary land. Planes don't fly like the Earth is curved and rotating, though.
You sure about that?
Yeah, I can show you documents.
Go ahead.
It's on NASA's thing.
Show it to me.
I really don't want to have to get up and my computer.
I have it too.
Right, if you're trying to play the little game with the 1987 NASA document about flat and stationary
There's many of them.
It's a computer model, not an actual aircraft model.
There are many of them.
That's already been explained
many,
many times. I don't need to go over it again.
Yeah, so it's equally valid for us to just say the plane flies over a stationary Earth, right?
No.
If you can say no to that,
you can tell the difference.
How can you tell if you're not taking it into account?
Excuse me?
How can you tell that the Earth is rotating if you're not taking it into account at all?
You do take it into account.
How?
Because because you cherry picked a NASA document from the 80s.
How do you take it into account?
Doesn't mean that NASA or anybody else thinks that
chill out. How do you take it into account when you just said you don't chase the runway sideways? You fly the plane the plane just flies 500 miles per hour that way, east to west, and it flies 500 miles per hour going the opposite direction. Equally.
What I very clearly stated was that is not a test of either the rotation or the shape of the Earth. Although landing a plane on instrument landing does require taking the radius of the Earth into account, because that's the way the instrument approach is designed.
Rotation.
So when it comes to the flight of descent, do you have to compensate for curvature?
No.
You don't?
Nope.
Okay. So whenever you land like east to west, if you're landing east and then if you're landing west,
right,
would you have to like slow down or speed up due to Earth's motion?
No.
No?
Nope.
So
Earth's motion has nothing to do with it.
So we don't compensate for the curvature whenever we're landing.
We don't do anything
and
with
then
curvature.
we don't do anything when it comes to the motion of Earth.
Curvature is
So Earth has to be a level stationary plane, right?
fairly
What effect do you think you would have to take for rotation?
You wouldn't have to. That's what I'm saying.
So if you wouldn't have to take into account rotation, why is that a test of rotation?
Because it doesn't. It's equally. As I'm saying, it's equally as valid for me to just say the Earth is not rotating. End of story. It doesn't take it into account.
It's also equally valid to say this isn't a test of rotation, so we don't know.
Okay. So how come planes fly like the Earth is flat? Then they
don't.
Yes, they do.
Who told you that?
I've spoken to pilots like.
I am a pilot. You're speaking to one right now. Tell me how often
do you adjust
into account the
how often
shape
do you
of the
adjust? How often do you dip the nose down to account for curvature?
Why would you dip the nose down? That was the very first video that I put out as a pilot in 2018 as to why planes don't have to dip their nose.
Does your gyroscope keep rigidity in space?
What gyroscope? You mean my heading indicator? Yes.
Right. So if you level it to the ground that you're taking off from, right?
Well, it starts there. Yes, you have to readjust it every 15 minutes due to your movement across the surface of the Earth and gyroscopic precession.
You don't need it, but you don't need to dip the nose of the plane then, like you just said, right?
Why on earth would you?
Because if you're flying on a ball and you always fly straight, and actually pilots fly with their nose slightly up to maintain altitude, right?
Correct.
If you never dip the nose down, you'll end up in space.
Why on earth would you think that? Why would you think?
The Earth is a globe.
Let's just go ahead and take that and continue it on.
Okay, I'll show you.
If I were to end up in space now, and you say, quote unquote, I fly straight.
I'll show you.
But no, you don't need to show me. I'm telling you. So if you fly
tell me all you want, but
laser, you're going to gain in altitude as you go across the ground because you're flying straight.
Yeah, but you never dip the nose down, right?
However, you don't fly straight. You fly at a pressure altitude above the surface, and whether that surface is curved or flat, it doesn't matter.
But you never
You're
dip the nose
flying a
down,
set
right?
Distance.
But what I'm trying to say
So
is you
flying a
never dip
set
the nose down.
altitude above the ground does not change whether it's flat or spherical.
Well, it does, because if you're flying over
Why?
a globe,
Why would 40,000 feet above a sphere be any different than 40,000 feet above a flat plane?
because if you're flying over a globe, you'll end up in space. I'll show you. 1 second.
Yeah, that's a basic misunderstanding that you have. You see that
It's
red
basic.
line right there? That is a level line to the surface of the Earth. It's the same elevation or altitude above the surface.
Can you define
Follow
flat
that
real
line.
quick? Can you define flat?
Flat is on a geometric plane. Can you define level?
Yeah, straight,
No.
horizontal.
Nope.
Oh, really?
Level is equal elevation above a surface.
Oh, really?
So
That's not what I
if
read.
an object is 5 feet above the surface and you have a
Wait,
whole field of
that's
objects
flat?
that are 5 feet above the surface, they are level to each other.
Hang on, did you say that was flat? The definition of flat?
Flat is a plane. It's a line on a plane.
See the diagram that my Rakir's got up? If
Yes.
you're flying a plane perfectly straight and level, you're saying you never dip the nose down. Why would you not end up in space?
Because you'd follow the red line. You're flying level, the same elevation
No.
above the ground.
Right, so then the plane's nose dips down.
Not relative to the ground, no.
So then you fly up in space.
Good Lord, the level
It's very,
of
like, I don't know if you're being
you have is
deceitful here,
amazing.
because this is like really basic, dude.
Yeah,
You-
I know.
First
I'm
you said,
surprised that you don't get it.
first you said,
Planes do not fly straight like a laser. Planes fly at an altitude above the ground, and if
Right.
the ground is curving underneath it, that altitude.
hang on.
It's
So
curving.
what if the ground is not curving and it's just flying straight and level like you just said? It's equally as valid for me to just say that the Earth is flat and you're flying flat over a flat plane,
It's
right?
not a test of flat versus
Why?
curve. It's a test of is it at the same altitude or not.
You'll gain
Level is
altitude. Hey,
defined
wait.
at the same altitude.
When you shoot a radar that bounces and it goes really far and it bounces off the ionosphere, that radar signal's gaining altitude, right? At
Yes.
horizontal?
Yes.
Right. How come the
And
plane
that's
going
not how
straight?
planes fly.
How come the plane going straight doesn't end up doing the same thing?
Because the radar goes in a straight beam, whereas the plane maintains an altitude above sea
You
level.
can't be serious. You're not a
I
pilot.
am serious. That's why
on,
you
dude.
have radar shadows.
So you're
That's
telling
that's
hang
why
on.
you can fly under the radar.
You're telling me your plane noses down without you knowing.
I'm saying the plane maintains an altitude and follows
No,
whatever.
no.
that
Answer
altitude
my
is above the
question.
ground.
In order to make that red line over the globe there, you have to curve the line, right, to draw it, yeah?
All right, turn the globe sideways and
No.
tell me where
Hang on.
plane that's
Answer the
directly
question. It's a
above-
very simple question. The red line. in
Okay,
order
the simple
to draw
answer
that
is
red
no.
line,
You don't. It's not.
you
Dipping
don't have to
its nose.
draw. You don't have to draw a curve. Are you joking?
No, I'm not. It's just basic
Wow.
geometry and spatial awareness.
Wow.
So if you look at that plane that's over there at the right side. Now hold it up. Now turn it so that the ground is directly underneath it. Tell me whether or not that plane is going down or up. It's
What?
staying the same.
So you're saying
It's in
you
level
don't.
flight.
So you're saying you don't need to draw a curved line,
You are drawing a curved line.
but then the
It's the
plane
same
goes.
distance
But
above
then
the
the plane.
surface of the Earth.
You're right. So the plane is nosing down without you knowing.
The plane is maintaining a height above the ground. It's not
Holy
nosing
shit.
down relative to the ground. It's
Buddy,
nosing
in order to fly around a globe and to go all the way around it, you need to draw a curved line around the globe,
Correct.
which means you have to nose down.
Not
Otherwise, you end up in
relative to the ground,
space.
you don't.
Holy
You're not
shit.
looking at this from the moon. You're
Oh my
looking at it
gosh.
from the ground.
It doesn't
You do
matter.
not have to dip your nose to go around the curve because you're not changing altitude.
Just tell me one more time. Does the plane's nose dip down? Yes or no?
No.
Holy shit. So it's equally as valid for me to just say if the Earth was flat and you're flying over a flat plane that you don't nose down, you're flying.
Not a
it'd be the
test
same
of
thing, right?
flatness or sphericity.
It would be the same thing, right?
It's not a test of that.
It would be
It's
the
not
same
testing
thing.
for
No,
it.
no.
You're testing whether or not it's
Hang on.
maintaining
It would
an
be
altitude.
it would be equally as valid for me to just say the plane flies flat over a flat.
You're not making any
Earth.
statement about the shape of the ground. You're simply
Yes, I am.
making a statement
It's
that it's
equally as
maintaining
valid.
altitude above the ground.
Bob, chill. It's equally
I
as
am chill.
valid. Okay,
But
it's equally as valid.
To interrupt my answers.
I'm trying to
We're
say
gonna be
something
done with
for
this
like the last
conversation.
5 seconds. You're not letting me. It's equally as valid for me to just say the plane flies over a flat surface.
It could be equally valid to say anything because you're not testing for it.
Holy shit. But if you're
You're not
flying
testing
flat
for the
over a
shape of
globe,
the
you end up in space. It's so simple, dude.
To you, maybe,
Yeah,
because
it's
you
so
don't
simple.
understand
It's so
what you're
simple.
talking about. But
I
those
do.
of us
I do very
who know
clearly.
the
And
difference
every time you'll end up in
between
space,
flat and level, you know the difference.
hence the plane dips its nose. So you're saying that the plane doesn't dip its nose down, yet it does,
No.
but you're not aware of it.
It's flying the same altitude above the ground. It doesn't care what the shape of the ground is.
Right. So if it's flying over a globe, how come it doesn't gain altitude over
Why
a
would
long
it?
distance? Because
It's
it's
maintaining
not nosing,
altitude by definition. That's what level is.
but it's not nosing the nose down.
Doesn't need to.
But then
Just
it will end up in
maintain
space.
altitude.
Can you do you see the drawing, dude?
Yeah, I know.
What's wrong with it? What's wrong with it?
That's a 2016 drawing from
What's
somebody
wrong? So what's wrong with
who
it?
has no idea
What's
what they're
wrong?
talking about.
But the thing is, pilots don't account for curvature, like you just said.
What makes you think that?
So when it comes to the flight of descent, do you have to compensate for curvature?
No.
You don't?
Nope.
Okay. So whenever you land like east to west, if you're landing east and then if you're landing west,
Right.
would you have to like slow down or speed up due to Earth's motion?
No.
No?
Nope.
So we
Earth's
don't,
motion has nothing to do with it.
so we don't compensate for the curvature whenever we're landing.
We don't do anything
and
with
then we
curvature.
don't do anything when it comes to the motion of Earth.
Curvature is
So Earth has to be a level stationary plane, right?
fairly.
Yeah, exactly. So it's equally as valid for me to just say it flies over a flat surface. Flat
It's
Earth.
not testing for it one way or the
Okay,
other.
let's say we're testing for it. It's equally.
You're not testing for it.
Let's say we're testing for it. It's equally as valid for me to say that the plane flies over a flat Earth.
Okay, if you are testing for it specifically, how would you test for it?
You
With
would
an airplane.
so the way you fly, like you just said, you level the gyroscope to the ground, and then you fly, right?
Okay.
And then
That's
you
the
land,
gyroscope is just for the heading.
and then
It has
hang
nothing
on,
to do
and
with,
then the gyroscope never processes downwards. The nose of the plane's not ever going down; it's actually up, right, to maintain altitude. So you don't nose the plane down. What plane did you fly?
That's not important.
Yeah, because I don't think you're a pilot.
That's fine with you.
Because
Good for you.
if you can't admit that if you just keep your heading on east, and then you'd end up south if you don't keep your heading on it, then I don't believe that you're a pilot.
If you're following the line of latitude, you follow the line of latitude, which is always east.
Yeah, but if you let's say you put your heading east and then make a marker where east is, but follow the marker not east, you'll end up south.
Okay,
if you
that's
just
not
keep going.
following a heading of east. You're going to drift to the south.
Yeah, that's what I mean. You'll drift
Yeah,
to the
but you're
south
not following east. You start
Yeah, that's
off
what I'm saying.
east and then cover up your compass and just go that same direction. You're not going to be heading east for long.
Yeah.
You're
Would
gonna
that
start
happen?
heading
Would that
south.
happen on the equator?
No, why would it?
Because Earth's flat.
Actually, on the Gleason map, if you were to start going east as you describe on the equator, you would immediately enter the southern hemisphere and go to the ice wall.
No, you would just follow east. You adjust.
No, look at it.
You would just adjust
Because
for
it's
east.
a circle, you'd be flying a tangent.
Hang on, is east and west
following
circles?
the latitude line from east to west.
On the
Oh, wait,
Gleason
Bob.
map, it's a circle, and you'd be flying a easterly tangent on that circle, which will take you straight out to the ice
Hang
wall.
on, is east to west
Every
circles, Bob?
In reality or on the flat Earth?
In reality.
In reality, east and west are circles. Yes, they're lines of latitude.
Right, so if you maintain east, you're doing a circle around the Earth, right?
Around the sphere, yeah.
Yeah.
Ask in reality or on a flat Earth. On a flat Earth,
Oh, wait a minute. I don't get on panels with this guy.
our east and west
You have to
circles.
leave or I leave.
Shut up, crybaby. Are
All
east
right,
and
bye-bye.
west circles on a flat Earth?
Yeah, I know you're scared, Bob. Bob, I don't believe
No,
you're a
I don't
pilot,
go
by the
on.
way. I'm
I don't
sorry.
go on panels with
Bye,
guys that molest
Bob.
children.
Bye.
Want to
Okay,
fly,
see ya,
Bob?
Bob. See ya.
You spent 7 months in court for felony sex crimes, and I'll tell everyone about it. And I got the
I know
articles
about
too
that,
if
Bob,
anyone
too.
wants to
So,
message me.
see ya, Bob.
Yeah. Later, Bob. We'll see you later, Bob. You crybaby, Bob.
Dude, there's no way he's a pilot, man. With what he said. No way.
He's an absolute moron, dude.
He's so, like, there's no way.
Oh, the lies we are told and believe because we fail to recognize them by using our own logic and critical thinking. I'm a retired Navy SEAL, sniper, scout sniper, and scout sniper instructor. I fancied myself at a time as being one of the best snipers in the world, certainly one of the best scout snipers in the world, which includes more than shooting, but also skillcraft. Some others would agree. The Coriolis Effect is bullshit. The theory is that with the Earth spinning on its axis in a direction of east to west, you would have to compensate for the spin of the Earth when shooting in a westerly or easterly direction. When the bullet would reach the target would either have risen or have dropped based on the spin of the Earth. Shooting north and south would be no difference. It wouldn't have an effect. But on a mission, if that were true, I would have to compensate at varying degrees, whether shooting between north and south, or correction, north and east, east and south, south and west, or west to north. Never once did I compensate for the Coriolis Effect. And we were driving nails, or at least hitting a man-sized target in the kill zone at 1,800 yards consistently every time. Along with other lies told about our universe and the nature of it, the Coriolis Effect is total BS. Certainly, a bullet drops when at distance dramatically because the velocity is decreasing. But as far as the spin of the Earth goes, no effect.
Yeah. So, Brian, how long did you guys train to account for the Coriolis effect when you were learning to shoot?
Never.
Never? That means never. Why not, Brian? If the Earth's rotating, then wouldn't you have to take that into account? Wouldn't that affect? Or
I got to correct you on that. There is a Coriolis effect supposedly in the training manuals, and I've seen them. Just never used them. Never had to use them.
so you actually seen them in a real manual, not made for
Yes.
public release, not labeled top secret, and made.
It's called a firing table. It's called a firing table, yeah.
Okay.
There is supposedly in there, but we never used it, ever.
Were you told not to use it?
No. Just never.
Isn't that because it doesn't, you don't have to start accounting for it until they say like over 1,000 yards or whatever, right?
No, I mean, no, I shoot a lot further. I shoot further than that.
Or not, maybe.
It's kind of like if you ask a geodetic surveyor, when does he use the math for the curvature? They know it, but they never used it. It's one of those things they're taught, but they've never actually used it.
That's why wind comes from all different directions. Wind is wild.
Bill Nye the Science Guy.
Background on the tanks to show you how precise they can be. When what we do calculate for, at least the computers and everything else, is things like barometric pressure, the ammunition temperature, the air temperature, crosswind, and any changes in those. And we demonstrate it, in schools and whatnot, of how 10-degree difference will make the round totally different, change. Yeah. But I can shoot east, west, north, or south, and it never affects if all those settings are in.
Nice. I didn't even. That's new to me. I didn't realize that. No, barometric pressure doesn't necessarily surprise me because that's like water pressure. If you've got especially because you're shooting distances, and you don't have to give away anything. But I mean, you're shooting 20, 30 miles roughly. I mean, if you're
no,
not for the long shots.
No, not for the long shots. I mean, we average, your probably tanks will shoot target engagements 2 kilometers, but we can shoot, around 4 kilometers or so accurately.
But,
on the move.
Okay.
So that's where the gyros and all that come in, but we can go across terrain up and down and hit a target out there.
Got it. Now howitzers can shoot. The artillery guys, they're designed to do the lob shots, but tanks rarely do any lob shots of any.
No, we don't do what's called indirect fire anymore. We're very direct. We like to see who we're,
got it,
shooting. But I will say
go ahead.
The rounds. So, and it's rare, but occasionally, somebody will mess up and shoot a round too high or something, or out of the range that we're supposed to. Mm-hmm. And one thing that we're taught to do is, we have to find out where that round went.
Ah, got it.
So we know all the calculations, given the angle and the temperature and the barometric pressure and all that, approximately where that round went. And they can go pretty far.
Got it.
Accidentally. But again, we don't count curvature of Earth to calculate where that round might have accidentally landed.
Good point. And yeah, let me address that here in a second. But because I want to clarify. So direct fire, that's target point to point. You looking at an enemy piece and engaging them, usually a fairly horizontal shot. Tanks used to be, which is why I brought it up. Used to be, they could park themselves, elevate the gun, and just start letting them fly. But you guys,
I think the M60 series was the last one to do that.
But that's it. Those tanks now, it's all about precision, and you guys don't, like you were saying, you don't take any random shots. It's all as accurate as possible. Kind of like a sniper.
Yeah, it's it's like a sniper. Once we shoot, they're going to know where we are. So.
Good.
Shots away.
Shots away.
No way.
I got the first bunker hit. I'm fine.
Astronauts to the moon.
And remember, we found with ballistics like 1,000 yards away that it was going to be about a 1.5 to 4 inch deflection. But now here, with a 30 kilometer at the maximum range, you end up with a deflection of 164 feet or 50 meters. That's a huge distance of deflection. So if they don't factor in Coriolis, they're going to miss their target every time.
All right, so this is the article. World record for longest long-range rifle shot was broken in Jackson, Wyoming. The world's farthest long-range rifle shot was fired Tuesday, surpassing the previous record by nearly half a mile. Pretty impressive, huh? The previous record of 4 miles, set in 2020, was defeated by a 4.4 mile target hit in the high desert of western Wyoming. The bullet took 24 seconds. Can you imagine? 24 seconds to hit the 8-inch bullseye. but breaking the record had been the goal for over a year. After setting the Wyoming state record of 3.06 miles in 2020, Scott Austin and Shepard Humphreys gathered a team of extreme, long-range enthusiasts to tackle the world record. This was the most challenging, difficult, frustrating, time-consuming, and yet rewarding professional project I've ever undertaken, says Humphreys. They began planning in late 2020. I'm sure you know where this is going. As always, they've got to mention in here somewhere, right, that we have to take Coriolis into effect. It's going to be required. Then began months of testing and wide range of systems like wind readers, custom steel blankets, optics. With this kind of shooting, nobody has yet figured out how to get first-round hits. This isn't the kind of thing where you just buy a new rifle, some ammo, and shoot the gun off. Bunkers protected the spotters from being hit as they were scattered, blah, 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 blah. Keep going here. After several hours of number crunching and aim adjusting later, their 69th shot hit the bullseye. Austin and Humphreys said that while their hit is not scientifically consistently repeatable, this makes it extra coincidental that the previous 4-mile record also landed on the 69th shot. Together, we've spent over 1,500 hours in research, highs and lows, blood, sweat, excitement, tears, with dozens of amazingly gifted people, businesses personally invested in the goal. Today, we've spent over 1,500 hours of research. So you'll see here, for the shot that made the impact, Austin gave the shooter a correction of 1092 MOA. I have no idea what this is, Spanish to me. Of elevation and 17 MOA, blah, blah, blah. As the wind value was the only one of several variables affecting the bullet's horizontal drift, spin drift, where the bullet angles in the direction of the spin, and the Coriolis effect, the rotation of the Earth by which the target shifts position while the bullet is in flight, also play a role at that distance. That said, a 1 mile per hour increase in the wind would cause 26 feet more bullet drift, according to Humphreys. So, clearly they threw Coriolis in here, and then I said, all right, let me email this guy and ask him straight up, can I get your, please, sir, Mr. Humphreys. Is that his name, Humphreys? Shepard something? What is it? Yeah, I forgot his name. Humphreys, something. Yeah, Shepard Humphreys, I think. So I said, can you please give me your calculations for Coriolis effect, because I don't understand it, and I would love to begin understanding it. I don't want to be like some loser here. Let me make sure that this is in a place I can squish this and show you the email that I sent and the email he responded with. What do you think he said? What do you think? He's got a good read on this? So you'll see here, he says, to start out the email, we did not take into account the Coriolis. It's important that you include it in that article, though, because we got to prove to people that the Earth is spinning, and these guys just hit a target 4.4 miles away, where the bullet was traveling for 25 seconds, and yet they were able to hit it without taking Coriolis into effect. And he says, as much of that is lost in the weeds with respect to the wind, temperature rising, constantly adjusting elevation, all the other things. The bullet's flight path is over 2,500 feet above line of sight. There's a lot going on up there, and we were unable to predictably compensate for it. If it had been an absolutely dead calm day, it definitely would have been one more variable we could try to address. But nobody takes it into account, right? And then he put here, not a flat earther, which I never said I was. So I don't know if that's just like a little joke or something. But yeah, he says, we have discovered at 3 miles and 4.4 miles that what the wind is doing on the ground or at the peak of a nearby 500-foot hill does not do a good job in telling us what's happening way up there where the bullet is traveling. So I guess because the bullet drops so much, you have to aim 2,500 feet in the air. Crazy. But I thought it was funny. They love to throw these things in the articles as if it's a fact, and then you just email the guy and say, hey, can I get your calculations? I just would like to see them. Oh, we didn't take it into effect. We didn't take that into account. We just, we don't do that. So don't let anybody tell you sharpshooters do when the people who have the very record for the longest shot ever, they don't even take it into account. Okay? Don't even take it into account, and that's hilarious to me. Hilarious to me. All right, let's close that one down.
Yeah, so it's nice that that record is out there.
Yeah, it's dope, dude. And then just some follow-up for those who don't know or may not hear the story but are hearing it for the first time. After Jaron emailed this guy in the video, he follows up with them anyway. And Bryant Myers, who turned into like an anti-flat earther, started harassing that guy and basically got him to like retract everything that he openly told Jaron and some other stuff that he shared with Jaron privately. And but yeah, Brian like harassed him he just bullied him into being like, oh yeah, it's definitely a globe. Like, that guy, I didn't mean it or whatever, So High, very high, but not the most high. That's from Lord Racer. Oh, hi, very high. Yo, what's up, dog? So anyway, just a quick recap on this video. This guy, Stephen Humphreys, thought it would be really tight to, set the world record for a long distance marksman. Retracted. It was Brian Myers had a video, where he had shared emails that he followed up on with this Humphreys guy, and he got him to say oh, it's definitely a globe, and kind of disavow what he talked about Jaren with.
Mm-hmm.
And but he went into some pretty good detail, and we can also derive a couple of things to give some supportive evidence for flat Earth, positive evidence for flat Earth, rather than a thing that could go either way. I think this is pretty irrefutable, even by high globe standards. So the idea here is that the Earth rotates under the bullet. This guy made a shot that was 4.4 miles away. He accounted for a lot of factors, he says, but none of them were the Coriolis. But when you read articles about it, the authors will talk about how they accounted for Coriolis. So Jaren emails the guy and asks him personally if he how he accounts for Coriolis. And what he replies is, "We did not take into account the Coriolis as much of that is lost in the weeds with respect to the 6 to 9 mile per hour wind, temperature rising, constantly adjusting for elevation, time of flight. The bullet's path is over 2,500 feet above the line of sight. So there's a lot going on up there, and we're unable to accurately predict or compensate for that. So keep in mind, if you're doing a shot like this, this is obviously very complex. There's a lot of factors to go into, a lot of things to consider, and we'll get into some of the super minute details of long distance shooting as we go on. But just think about this. So let's say it's a given, for sure the Earth's rotating under us. This is a thing that we have to account for, and this bullet guy has to account for it. So how would you account for it? You would shoot in the direction of the spin, right? So you would shoot facing east, so that you could so that the speed of the bullet would match the spin, so that the target wouldn't be rotating underneath you. So you would just by virtue of facing east, you would by virtue of facing east, you would reduce the factor of that Coriolis effect as much as possible, really, because I looked into it. I don't have it specifically pulled up on this yet because I was kind of halfway through it. But the composition of the bullet that they used, and at the latitude or whatever that they're at, it actually closely matched the rotation of the Earth. So that would have been a great way for them to compensate for that. But we're going to find out here that they didn't shoot in that direction. They actually shot in a different direction, and we'll get into which direction here in a second. So that was his publicly available details that he says on Coriolis, from the guy who pulled the trigger, from the guy that analyzed everything, figured everything out, applied all the factors, decided that the spin of the target underneath them at a flight time of, I think it was 25 seconds.
Yes, 24 seconds.
Yeah, at a flight time of 24 seconds, the biggest possible factor of the entire shot. He was like, you know what, the fucking wind is gonna outweighs that. So we'll just go ahead and disregard that. So, like I said, shooting east would have been a great flat Earth proof. Globe proof. So what happened here? You go through their blog. I think the website is I don't have it. I cropped it out on here. It's nomadrifleman.com, something like that. Anyway, if you look up the record there, he shows the moon setting, or moonrise, whatever, and the time of which they were at, and the target was facing there. So I looked up which direction he was facing, shit. So when you get into long distance observation or long distance shooting in the military and stuff, I was reading a book, and this is just to give some citation to that. So anyway, this guy was one of the first founding members of Delta Force. He was really good at long distance reconnaissance, they call it. And one of the things he talks about in the training that they undergo is, they get really good at meditation and like physical discipline and mastery of their body, because when you're shooting at not even distances of that of 4.4 miles, but of like 600, 700, when you're getting into that, when you're getting into like 1300, 1500, the everything becomes a huge factor, even your heartbeat. So they'll slow their heartbeat down, they'll slow their breathing down, and they'll shoot in between their heartbeats. And that's a quote from the guy, one of the founding members of Delta Force, saying all that. Never mentioned once in the book that they also account for the Coriolis. But I just think it's an important factor, or important thing to mention, of all the things that they possibly account for, the fucking target rotating under them would more easily be accounted for by shooting in the direction of that. So you would pick a location to shoot at that had a target that you could hit east going that way. You wouldn't just go any direction. You could even make an argument that shooting west would be decent. Obviously east would be optimal, but yeah, shooting west by southwest is fucking full dog shit for the globe. So that about wraps up that.
I did the math. I didn't do it. I just did it right here. It looks like if you're looking at 24 seconds, tell me if I'm wrong.
Yeah.
If you're looking at 24 seconds at 4.4 miles, and of course you had a lot of lob involved in that. Am I right or wrong that I don't know how far off I am? Is that like a 600 or 700 mile per hour bullet? Am I right or wrong on that? About 600 or 700 miles per hour. Bullet travel 4.4 miles.
That sounds exactly what it was, and I think that's what the latitude or speed would, the rotational speed was at latitude too, because that was in Jackson, something, Wyoming. So
yes.
So it was about that. So they definitely would have shot west, because when you're doing that kind of stuff, you're all about min-maxing. You're not trying to fuck around and shoot in the opposite direction of where the target's rotating underneath you from, where you're going to have 24 seconds for that target to be in a new location relative where you originally fired the gun from. So that pretty much destroys the notion of Earth rotating under a target.
Speaking of the Coriolis effect, Master, you say that helicopters and hot air balloons can hover over the spinning Earth for hours upon hours, not having to worry about or calculate any kind of movement, because the atmosphere turns in exact unison with the globe Earth, right? Then why do you also claim that snipers firing bullets absolutely must factor the direction and spin of the Earth before making their shots? Why would the Earth spinning under the bullet for split seconds be so impactful, but yet Earth spinning under planes and helicopters for hours at a time be completely negligible? Isn't this another globe-Earth double standard, Your Honor? How is the Earth spinning beneath the bullet, but not the balloon? What if a sniper was shooting from up in a hot air balloon? My lord, my liege, where did you go? What's the answer? What do I say to the flat earthers?
Let's talk about the so-called Coriolis force. Many people claim the Coriolis effect proves the Earth is a globe. And I think it's interesting how people usually refer to it as an effect rather than a force. I have no complaints about that, because it is a fictitious force, very much like gravity. But you don't see very many people saying the gravity effect. We'll come back and talk about the gravity effect in another lesson. But before I get to that, I want to talk about the Coriolis effect and the Coriolis force, and then talk about how it is a fictitious force. And before I do that, I want to address the globe Earth claim and tell you what is wrong with it. Science ABC describes this claim in further detail.
Interestingly, cyclones in the northern hemisphere of our planet spin in the counterclockwise direction, while those that occur in the southern hemisphere spin clockwise. In fact, this is true for all storms.
We'll stop right there. Here's our first problem. That is utterly false.
Tornadoes usually rotate counterclockwise, but what happens when one is spotted turning the opposite direction?
Inside Science.
A tornado is a violently rotating column of air that extends from a thunderstorm, and that's the general definition of it.
A tornado in the northern hemisphere usually spins counterclockwise, but on rare occasions it can twist clockwise and is called an anticyclonic tornado.
Well, it all started with actually video. We got a video on our TV station from a lady that lives in the neighborhood where it went through. And I said, that thing was going clockwise. And I kept looking at it, and so then finally when we had a chance to really sit down and look at it, when we're not on the air, you can see it was going clockwise.
You can also see the anticyclone here on the radar. Red indicates winds moving away from the radar, and green shows winds moving towards the radar, creating a circle.
That's how you find a tornado, red next to the green. Well, you look at the red next to the green, it was flipped opposite to a clockwise, sure enough.
Inside Science. If you enjoyed this edition, follow us on the web and social media.
All right, so there's the first hole in their claim. Now let's let them continue.
This happens due to the Coriolis Effect, a physical phenomenon named after the French mathematician Gaspard Gustave de Coriolis.
Wait, hold on again real quick. Let me explain this. Wikipedia illustrates the Coriolis effect on a turntable, merry-go-round, or carousel. If you were to sit on a spinning merry-go-round and have someone in the center toss a ball at you, that ball's trajectory would appear to curve. The apparent force acting on that ball, causing it to curve in the air, is called Coriolis force. And just like gravity, we can describe it, we can say what it does to other things, we can measure it, and we can predict things with it. However, just like gravity, the Coriolis force is an illusion and is completely imaginary. This is why both gravity and the Coriolis force are referred to as pseudo-forces, or fictitious forces in science. Concerning the Coriolis force, the truth is revealed when we step off of the merry-go-round and we see the ball move in a straight line. Alright, now I'll let them continue.
Standing at Earth's North Pole, if you were to shoot an arrow at a target in the southern direction, towards the equator, the arrow would land west of the target, as the Earth rotates from west to east. However, if you shoot an arrow from the equator at a target towards the North Pole, then the arrow would land east of the target. Similarly, in the southern hemisphere, the arrow shot from the South Pole towards the equator would land west of the target, whereas the arrow shot towards the South Pole would land east of the target.
But remember, if we step off the merry-go-round, we should see it move in a straight line.
The same thing happens when winds, storms, and cyclones in the northern and southern hemispheres travel from and towards the equator. In both hemispheres, winds traveling towards the equator are diverted towards the west, while winds traveling towards the poles will curve eastward. But due to the presence of low-pressure zones, these winds follow a circular path. This is why cyclones and hurricanes in the northern hemisphere spin counterclockwise, whereas those in the southern hemisphere spin clockwise.
Again, that is false. Not only because of the existence of anticyclones, but also because if you were to step off the merry-go-round, you would see the storms moving straight. The Coriolis force is also called an inertial force. Inertia is the property of matter by which it retains its state of rest or velocity along a straight line, so long as it's not acted upon by an external force. And if the Earth were actually a spinning globe, in which direction would the winds be moving? They would be moving outward like this, just like any object on a spinning merry-go-round. Yet look at the direction they claim these storms are flying. North and south? If I were to hop on a merry-go-round and spin it around really fast, do you think it would launch me upward? Nope. So if this is not caused by a spinning globe Earth, what is causing this on a stationary flat Earth? Well, one of the vocabulary words that you should really familiarize yourself with, if you haven't already, is the term jet stream. We usually bring this up when talking about plane flights, but jet streams are just fast-moving air currents at high altitudes. These air currents can reach up to 250 miles an hour, and when those air currents meet resistance, they curl out and away from the air current, and the direction of the curl depends on which side of the current it is on. So if it's on the right side of the current, that curl will turn right, and if it's on the left side of that curl will turn left. Now, Jeranism and the Globebusters have a really cool website called bobwinds.com. It works in conjunction with the US National Weather Service, and it shows the wind currents throughout the world. All of these big red, pink, and white areas are the major jet streams, and if you ever wonder how planes are able to travel so fast in the southern hemisphere, that's how they do it. Now, I've gone and zoomed in here for you so you can have a closer look. And as you look right off the coast of Alaska here, you can see this jet stream. Please notice how if you're moving with the jet stream, the wind on the right is turning clockwise, and the wind on the left is turning counterclockwise. It really isn't that rare of a thing. You can even see the same thing on a globe. This is earth.nullschool.net, a completely different website, also getting their info from the US National Weather Service. So here I'm going to go and adjust the height of the winds we are looking at. When it comes to air currents, as odd as it is, they determine height based on pressure with a system called HPA. 1000 HPA is about sea level, and the jet streams at 250 HPA are the ones that have a lot to do with their major weather patterns. And right off the bat, take a look at this clockwise wind rotation. And oh look, there's another one. And both of them are north of the equator. They are not that rare of a thing. So, storms do not curl because the Earth is a spinning ball. And the direction of a storm swirl is just dependent upon which side of the jet stream it is on. Nothing more. Thank you for watching.
Looks pretty wild when you look at it that way, especially when you look at the ocean currents and the, let's see, let me overlay the waves. And what was it that I had before? Yeah. This is showing the currents as well as the temperature. And if you sit here and spend time playing around with this website, I mean, it's a pretty cool website. And again, this is the logo on the UN flag. The various currents and temperatures and everything make a lot of sense on the flat Earth model, where these hot temperatures right here was essentially the equatorial region on the globe model. This is where the sun and moon would be going around, causing those areas to be warm and everything. But everything seems to just, I don't know, it just seems to flow a lot neater and seem to make a lot more sense on this map than on all the other ones. Maybe it's just me, but
you can get so many real-time attributes about the Earth, from carbon monoxide surface concentrations to sulfur dioxide. You can see the heavy dust concentration, the particulate matter. I particularly liked it for the winds, but they also had ocean currents and waves. But the winds, to me, were amazing. You could check the winds at different altitudes. You could check wind speed, temperature, humidity, wind power density, precipitation, cloud water, mean sea level pressure, and the Misery Index, all plus a bunch more. But now the AE map is gone. Yes, the map that made sense, because of course we're looking at the globe here where things don't really seem to jive. We got waves and winds going every different direction, swirling around, making a mess. But if we flip that to the AE map, well, what do you know? Things make sense. So it was an excellent tool, regardless of whether or not this is the map of the Earth or not. It seemed to give us an idea of what's going on. You got the red area there where the sun and moon travel around in a clockwise direction. Then when you flip it over here to the globe, again, you've got waves and things going in different directions. You've got some going up, some going down as if they're going towards the equator. You've got things going away from the center when you get towards the poles. It was just a utter disaster. And so it was an awesome tool. It helped people see that the ocean currents, waves, winds aloft, the jet streams, even heavy dust concentration made no logical sense on the globe, and yet made all the sense on the AE projection. And people were starting to get it, because we talk about Occam's razor. Clearly, it takes a lot of assumptions and a lot of beliefs and a lot of nonsense theories to make it work on the spinning ball Earth with the attached atmosphere that's velcroed to the Earth, and you're flying at speeds you'll never be able to know or test. But on the azimuthal equidistant, Things simply made sense.
So check this out. It absolutely would. So if there's an ether vortex at the center of the North Pole, right? So assuming like a Gleason's map, for example, there's an ether vortex extending out over the plane from that. When you're at the, say, the northern hemisphere section, right, that's going to experience a translation of motion in accordance with the or in accordance to the west to east motion, right? And then as you get further out on the plane, the ether vortex is going to be higher. So there's a loss of that translation of motion. So as it gets closer to the ground, there's that loss is going to create a counter rotation, right? So that's going to produce a literal Coriolis effect in the tropical storms. Like, so for something that's really big and high in the sky, it's like that's definitely it's definitely going to get a translation of motion effect that would definitely cause that. So when people are like storms, you have a preferred clockwise, counterclockwise rotation in their respective hemisphere. Yeah, they absolutely do. But the same exact thing would happen with an ether vortex and an ether wind, with being the translation of motion of that vortex. So these effects are indistinguishable from what they call so-called Earth rotation. And as I said earlier, it's a mere coordinate system transformation to high ether wind and attributed to Earth rotation. And that's what they've done. Like, I'm reading these papers here. Like, for example, this guy. So similarly to how I'm saying that there's a stationary non-rotating Earth with respect to a rotating ether, when this guy's trying to fit it into the heliocentric paradigm, he's saying maybe there's a local stationary ether that's entrained with the Earth, and then the Earth is rotating through that, and that's causing this varying propagation thing. And then because it's localized to the Earth, that explains why they don't have to account for the orbital velocity. I mean, they're effed, bro. Like, if people understood, if like more people,
understood, yes.
Yeah, got out on that, like. It's literally like their whole framework is gone. It's gone. And this is
the pendulum readings. And so if you're wondering how this would work, just if you need a visualization, this is kind of how that would work. So you have your sun moving through here, and it's doing this on its analemma and going up. It's actually getting higher and lower and going back and forth throughout the year. And as it's going in this circle here, and the moon would be doing the same, similar, you kind of induct ether inwards. So let's say this is a racetrack of ether. This is getting inducted inwards and causing a spiral. And my estimation is that's why we have hurricanes that spiral this way and do this in the north, and cyclones that spiral this way and do this in the south. And it could very well be also why we observe pendulum precession to roughly fit sort of a similar geometry, right? Now, just if you get into the details on that, people will try to tell you that pendulums perfectly match Earth rotation, and we calculate Earth rotation using a pendulum. Always challenge them for their exact sources on that, and really look, because it's not as straightforward as they'll pretend it is. And if they get you with one where it actually matched, they got lucky, because they even have, if you go and look at documentation just for like a museum pendulum, they have electromagnetic systems in place to keep the pendulums in expected precession values. Because they don't want to have someone come into the museum someday and just suddenly find out, like, oh, what do you know? The Earth's not moving. That's crazy. No, they have a thing in place to keep it doing exactly what they want. And it's kind of crazy to think that they wouldn't have to have something like that, even if it did match a perfect Earth, precession, Earth rotation precession, which, we won't go too deep into that at the moment. But even if it did that, humidity, wear and tear, like it's crazy to think that they wouldn't have to do something like that no matter what. But it's just, my point is that this is not substantiated in the way that they'll try and gaslight you into thinking that it is substantiated. And but now the Elias effect, the periodicity, that has been corroborated. And here is a Harvard lab, Saxel and Milder and Allen, and in 1970 they published this, and here is them measuring the Elias effect. So during a solar eclipse, pendulum precession anomalies. So here's a standard day, that old daily periodicity, the Earth getting faster and slower, they would say, spinning faster and slower. But yet here is the Elias effect. These are not the same. And they say here, so there's a relative increase of about 2.7 times 10 to the negative 4 were recorded, and that would require an increase in our tension of 1.2 kilograms. This is 5% of the total weight of the pendulum bob, and is far greater than the classical theories of gravitation can explain. Results of this magnitude have been consistently observed in Harvard over a period of 17 years. Our results are about 10 to the 5th times as great. Move on here. So, eddy currents. They were discovered by Foucault in 1851, and these unequivocally exist on the Earth. There's circulating currents that are induced by a moving magnetic field, and the flow is induced perpendicular to the magnetic field. It induces Joule heating due to resistive effects, and it was discovered. And Maurice Elias believed that eddy currents on the Earth were the key to the precession of the pendulum. So let me just go full screen here. Here we go. So just going to read through Elias's quotes here. Again, we see that the total amplitudes of the 13 components above for the June to July 1955 azimuth series are of the order of half of the Foucault effect. The forces involved are therefore of the order of magnitude of the eddy current force corresponding to the, all I have of that. But yeah, it's corresponding to the eddy current force. And then he says, in both cases, the angular deviations observed per unit are of the same order of magnitude as of those corresponding to the eddy current effect. We can deduce that the forces involved in the observed perturbations are of the same order of magnitude, of the Foucault effect. So these deviations are totally inexplicable in the framework of gravitational theory. And if it looks weird, it's because it's translated from French by an AI. But that's from Maurice Elias's 1997 the anisotropy of space. Anisotropy of space. So let's get into cyclones and hurricanes.
Real quick, Toby.
Yeah, what's up?
That last sentence on the slide. Can you go back to the last sentence? So they're totally inexplicable within the framework of current gravitational theory. Is that because it would suggest that like electromagnetic forces are causing motion when, you know, those are supposed to be like way stronger than gravity? So that would kind of like those two things would contradict with each other if that was happening. Is that why it's inexplicable? Like, why is it inexplicable?
Yeah, essentially. Especially because they try to invoke gravity to explain the precession of the pendulum along with the rotation of the Earth. So, you know, like there's a specific rate at which the precession should occur. So if the precession occurs at any other rate, yeah, it implies that there's more going on within the motion of the pendulum and of, you know, that would basically imply all of Coriolis, right?
Yeah, except the fact that it changes during an eclipse, if it was due to the Earth's rotation, the Coriolis effect, and the pendulum precession, it would have to mean that the Earth is like spinning faster, right?
Yeah, which is, I mean, obviously that's not occurring during the
Right.
eclipse, right? Like this, it's not just speeding up during the eclipse and slowing down during the eclipse.
Right. Okay.
All right, so back to the presentation here. Oops. Sorry about that. All right, so cyclones and hurricanes. And let me actually go here. So they start as tropical storms over warm ocean water, and then those tropical storms develop high winds and a low pressure center. And hurricane season, just if anyone doesn't know, hurricane season is the opposite in the north than it is in the south. Kind of common sense, right? But hurricanes never occur on the equator. And they never cross the equator. And actually, if you look in the lower left picture here, you see these arrows that diverge outwards. When you see this curve here, you kind of would be thinking, if you haven't like looked at cyclone geometry and hurricane geometry a lot, you may think that the cyclone or the hurricane would be doing a rotation, a clockwise rotation, right? But it's actually doing a counterclockwise rotation in the north. And so that counterclockwise rotation is occurring as the hurricane is doing this curve back outwards. And all of them kind of do this like outwards motion away from the equator. So you have essentially like a sun motion that goes through here, right? And as the sun motion occurs, it pulls an inward rotation that then moves outward. And just to visualize what that looks like from a top-down map, we have this here, right? So you would have the sun going around here, and then you would have the cyclones and hurricanes would be the cyclones in the south would be going this way, going clockwise, and then the hurricanes in the north would be going counterclockwise. So I think that this is related to the eddy currents that are being, that are manifesting on the Earth as a result of the sun and the moon going throughout their motion throughout their sidereal motion throughout the year. And that actually goes pretty well with this as well, right? You've got these massive spinning storms that are occurring as the sun moves up and down on its analemma.
This would be a meridian flight, north to south. Now, this, of course, if you fly north to south, you're going to have the Earth spin underneath you. Okay, and this is, I even brought this up in the debate a little bit. So you would have to adjust for this. So they claim, of course, we know that they claim Coriolis. And so like when you shoot a bullet allegedly north to south, then the Earth drifts underneath it, right? And so you have an inertial and accelerative frame of reference. You have two different frames of reference to have that difference. So the question is, well, then why doesn't it affect the plane? Why doesn't the plane have to account for it? Last night he said that it does. So anyway, when you come down here, this kind of explains the Coriolis, right? The idea of it, and you have to have an inertial and accelerative frame to observe the effect of Coriolis, which is a real effect, we know, just not Earth-based Coriolis. So here he gives a specific example from Frankfurt to Abuja, right? So if you were going 576 kilometers an hour during a 5.5-hour flight, then the Earth would move 3,171.8 kilometers to the east, and you would have to adjust for that. Now, again, they claim that basically what a lot of the globe earthers will tell you is that the atmosphere, like he says here, is part of the Earth and moves in lockstep with it, and thus carries the plane with it like a river, right? That where it doesn't have to account for it because the Earth atmosphere carries it with it, which is contradictory to the idea of Coriolis. Again, you have to have an inertial and accelerative frame. And so
it's also contradicted to the idea that we have winds going in all different directions and all different altitudes.
Yeah, exactly. Exactly.
At all.
And that last night that dude was saying that the wind is the Coriolis. I'm like, no, the wind goes in all directions. So this is now a lot of flyers have probably heard this, right? Like he says right here, let's see here. It's claimed that the Coriolis which is responsible for the fact that the plane hits Abuja without need to do anything about it, contrary to what the animation shows is actually the case. And so it's fundamental physics of motion, not so much motion, but energy expenditure for the goal of overcoming conservation of angular momentum. So simply put, if you're flying over this globe right here, where it's good up here. Yeah. So the Earth's spinning underneath you. So you would have to adjust the plane this way. You have to use the rudder to bank over while simultaneously accelerating forward to catch up to the spin of the Earth. Now, planes don't do this. They have a constant speed. They maintain a constant speed relative to the static pressure around the plane. So they don't actually do this, and that's autopilot doesn't do it. And if they want to claim that it does, which that's what the guy claimed last night, he was just very ignorant of the subject, though. Then you would have to explain why people that fly manually, then they don't know how to do this. They don't do this. That's not what happens. You adjust for wind. You don't adjust for the Earth spinning underneath you. Again, you have to bank and accelerate forward. So you'd be adjusting for wind and factoring in the Earth spinning underneath you on top of it. It's not some magical equation where it all just works out, and that's basically what they claim. So this is where I ended up going with it. Now, this explains it pretty well. This right here alone debunks the globe. You can't claim the contradictory positions that there's an inertial and accelerative frame to give you Coriolis, and then simultaneously that the Earth drags the atmosphere with it perfectly. Now, you get all kinds of answers when you bring this up, but none of them are satisfactory. I think this is very, very damning. Okay? So again, they're trying to claim that the atmosphere moves in lockstep with the Earth effectively. Now, like if you have a blender, the outside of the blender is going to lag behind the central part of the blender, right? Everything in the blender, further out you get from the central point, is going to come further and further behind the central mechanism that's rotating.
It's
just
the hinge and doorknob effect, right?
Sure, yes. And just simple fluid. It's simple fluid dynamics, right? Look, it's well known that this is how anything that's fluid will behave. So what this means is the higher you go up above the Earth, the atmosphere is going to have to be going faster and faster and faster. Really simple concept. If you travel a greater distance in the same amount of time, then you have to go faster, right? And so as you get higher, the circle around the Earth gets bigger and bigger. And so the distance traveled of the air traveling around the Earth or with the Earth gets greater. And so it would have to go faster to move together. Now you get two different answers, of course. Some say, oh, it does drag behind the Earth. And some say, no, it moves in lockstep with the Earth. They can't get their story straight. This is why Neil deGrasse Tyson and people like this can't address stuff like this too publicly, although he does say that the Bengals literally lost a game because of a field goal kick and the Earth was spinning underneath it.
Exactly.
So, yeah.
What is the mechanism? And they never, ever, ever specify the mechanism at which this ever increasing altitude of air increases its speed. They never describe that mechanism.
Exactly, dude. So I found this out.
Lockstep with the Earth, but it's leaking at the same time with geocorona.
Yeah, the only thing it could possibly be in any remote explanation would be friction with the ground. But if it's running at friction with the ground, that means that it would be rotating that air at 90 degrees from the direction that it would need to be going, which ultimately would cause a huge amount of turbulence in the atmosphere, which isn't happening, which means it's all bullshit.
Exactly. And so the law of conservation of energy and momentum is going to dictate that, like he said, there has to be a mechanism that's going to introduce energy proportionate to the increase in altitude to give you a proportionate increase in speed. Right. And now, like he said, they never offer a mechanism for this, and the friction doesn't work. Right. The idea that there's this gigantic gravity well based on the mass of the Earth displacing the fabric of space and time. There's a giant gravity well around it. Right. And that's your only cause of friction. Well, this isn't going to be able to give you the increase in energy. You need a separate mechanism. Like without an additional introduction of energy, it violates the law of conservation of energy and momentum. And to, illustrate the concept and principle to people, I just bring up the laser, right? Like when they shoot the laser through glass and it allegedly slows down by 30% and then speeds back up when it goes outside of it. That would violate the conservation of energy and momentum because it would have to have additional energy introduced to speed back up. It can't just magically go faster without more energy being introduced. Now, what they claim is that the laser like takes all these detour routes and it travels a greater distance at the same speed. And that's why it looks like it slows down. Of course, that doesn't work because the laser actually exits the same place that it enters. But just to elucidate the point, the laser couldn't speed back up. So you have to have energy introduced to it for it to go back to the original speed. Same thing with the Earth. Now, they need a mechanism that introduces energy to the Earth, and it does so in such a way where that energy is proportionate, like it proportionally increases from the surface up. Like it can't just be some random piece of energy. So I've heard them freak out and try to name stuff and it never works, like solar winds and stuff. So if the atmosphere is dragging behind it, then again, the Earth would have to account for it, right? And it can't be moving with it in lockstep because there is no mechanism and that violates the law of conservation of energy. And then where it gets even worse, because they don't have an answer. They do not have an answer for the mechanism. They never have introduced one. No one knows the answer. They just say things, right? So then it gets even worse. They claim that at the top in the thermosphere and above, that the atmosphere is moving faster, up to 30% faster than the Earth. Okay, so now we need a mechanism of energy being introduced from the surface all the way up, meaning 1 inch off the ground is moving slower than 1 foot off the ground, right? All the way from the surface up, you need energy introduced. And then when you get to this top part of the atmosphere, you would need an additional mechanism introducing even more energy to get the atmosphere to go 30% faster than the Earth. And now the highest levels of academia admit they have no answer for this. They don't know what it is. They make up stories about Venus and try to claim they think it has something to do with solar winds, but solar winds go in all directions and are not consistent. So that doesn't answer the question. And so this is called superrotation, right? So superrotation alone debunks their claim of the atmosphere moving with a ball Earth, whether lagged behind it or not, because you can't invoke an increase in energy or speed without a mechanism that's introducing the energy. right? And so that violates the law of conservation of energy. If you're in violation of the law of conservation of energy, you are immediately dismissed. It is immediately falsified. You cannot go in the face of that, right? I mean, and everyone that knows anything about physics knows that you can't go into the face of this. And so basically the summary of the argument, I've had no way to answer, you name the credentials, 10v1, no one can come with an answer, is, in summary, the whole argument is, if you claim Coriolis, you need an inertial accelerative frame to get that difference. You can't then turn around and contradictory or make a contradictory claim that the atmosphere moves in lockstep with the Earth, and we know that in reality it would drag behind it proportionate to increase in altitude. So then the higher something goes up, the more it would have to correct for Coriolis. Now, this never happens in reality. Planes do not do this. They just adjust for wind and static pressure relative to the plane. They maintain a constant speed. They do not bank relative to Coriolis and then accelerate forward to compensate for it. In addition, you would need an energy source introduced, a mechanism that introduces energy from the surface all the way up. And it would have to be an energy source that's proportionately introduced from the surface up, that violates the conservation of energy. And then when you get to the very top of the atmosphere, they claim it goes even faster. You would need a second mechanism that introduces even more energy just at the top of the atmosphere that would allow it to go up to 30% faster. So regardless of if you let them skate by with the first 3 points, the super rotation debunks them as well. And so I think that this is beyond a death blow. You'll never hear them bring up anything but east to west, great circle routes, right? And of course, you can have a circle on a flat Earth, right? But you can't fly on the meridian, the north to south on a globe. It just literally the fact that we don't account for the Earth moving, and that we just fly, assuming a stationary Earth, completely debunks the idea that the Earth is spinning underneath the plane or with the plane either way. So, yeah, that's pretty much the whole idea. He goes on to explain like a solenoid magnet would give you this like this motion on each side. He then has a demonstration. It's pretty cool. Then he has the Bob Wins picture. This is actually from the original website, I think. So this guy's crushing. He's pretty cool.
The null school?
Yeah, I guess so. I don't know what it's called.
Yeah, well, yeah, earth.nullschool.net was the original, and of course they removed the AA projection.
Right. Yeah, there it is, null school. And he's like, they took this off, but they'll give you something like this that's literally without any value.
That's like totally condemning.
Looks like a butterfly.
The Winkle Tripleman or whatever it is.
Well, we know that the military assumes a flat, non-rotating Earth for all calculations when it comes to their firing tables and their flights, so that pretty much confirms it.
Yeah, I mean, it is absolutely mind-boggling the amount of evidence that flat Earth has, and that all of it is just ignored. Oh, well, I don't even know what they make up for excuses these days, you know? But I mean, we have all those hundreds of documents that talk about all tests being done on a flat, non-rotating Earth, and they act like it's no big deal. It's like,
even for
no,
satellites, it'll say that.
Yeah, it's like it's a huge deal whether or not it's done on a flat or non-rotating Earth. If in fact we are on a globe Earth, it is a huge deal.
Yeah, and then here, this is the last part. So torque is defined as change in angular momentum, and the amount of energy needed to do that is the integral of torque applied over time. So there's an energy expenditure necessary to increase the momentum of the plane from that of Frankfurt to Abuja, but never the airplane captains asked to account for the extra energy which would have to come in gallons of fuel. Another consequence of spin, which I think this is beautiful, would be that your plane would get lighter when you start east as compared to starting west, as well as being latitude dependent because gravitational acceleration is not related to rotation. Axial acceleration, on the other hand, is. So your angular displacement is not primarily related to the rotating Earth, but to the dynamic origin, the center of rotation. Starting east increases angular velocity of a plane, and with it, axial acceleration starting west decreases angular velocity, and with it, axial acceleration. And when you subtract these accelerations from gravitational acceleration, according to the diagram above, the difference is a smaller value for the net value of gravity towards east than it is towards west, and thus you are lighter in one direction than the other. And so this would all have to be accounted for in the way that planes are flown, and none of them are. So it's not as simple as saying, oh, well, the Earth is magic and it's spinning and curving, but we fly it like it's flat and stationary. No. You can't do that. If you fly it like it's flat and stationary, that debunks that it's a ball that spins even when you invoke gravity. Even gravity in its current paradigm, unless you just want to make up some new one where it's never consistent and it's dynamically making all kinds of things happen randomly. The point is that even with gravity, you can't explain like these 5 fundamental problems outlined in this. And I've asked everyone you can imagine, physicists, astrophysicists, PhDs, you name it, and no one can debate it.
Yeah, there's no answer. It simply doesn't fit their paradigm, and yet throughout this whole thing, and what was Amy saying last night? Oh well, we prefer to go with the scientific methodology, which will tell us all this stuff. It's like, no, the scientific methodology in this case would tell you that none of this hypothesis is matching reality, and therefore you need to get rid of it and come up with something new, right?
Yeah, exactly.
The globe, it just doesn't make any sense at all. And they actually believe, they talk, well, basically they're talking the talk. They're talking the word salad, making it sound really good, but when it actually comes to being specific about how things apply, it ends there. And they can go no further. And it's just amazing.
Yeah, and it was a great quote. He ended it with explaining again. So, like, the difference is a smaller value for the net value of gravity towards the east than towards the west. So, thus, you are lighter in one direction than the other. This would be accounted for in fuel consumption, along with the actual Coriolis effect moving under the Earth itself. And 85% of plane tickets is fuel consumption. We know there's a little bit of sketchiness with that whole thing. I think it's blown out of proportion, though, personally. But either way, this would be a major component that you had to adjust for. And so he says, many people are aware of that, of course, much more than you would think. But the public and peer pressure of the dogma is so great that it is practically tantamount to social, if not professional, suicide to admit that. For all of you who fear this social pressure, here's how people are considered to rank among the greatest scientists serving in the highest positions in research, and the educational system did not fear to express what evidence suggests. And we covered a bunch of these quotes. I won't read them, but in my heliocentric my geocentric presentation, where these are the people explaining that, well, it's actually just philosophy and there's no evidence that the Earth is moving, et cetera, et cetera. So, yeah, I think this is pretty cool. I think that flat earthers should be able to kind of wrap their mind around this and just present it to people. There's no answer. I mean, what an intelligent person does is they try their best to come up with an answer for the other side. And if they can come up with a decent one that's actually viable, then you don't bring that up as an argument. And I tried everything. I racked my brain. I asked the best of the best that I could find. There is no answer. It's violative of the energy of conservation of, or the law of conservation of energy and momentum, right? Angular momentum. And the ball is dead here. So the Meridian Great Circle flight debunks the globe definitively, irrefutably. The fact that we fly commercial planes or any plane north to south without accounting for curvature or spin specifically debunks the globe Earth. So I think that's a really good one to kind of highlight in the future.
I agree. And that's a great point. It really is. And it's just another piece of the preponderance of evidence that, flat Earth has got in the bag. And, we got nothing but gold in our bag, and the ballers, they got nothing. This is amazing.
I think Owen Benjamin should do a flat Earth pilot, like he did the flat Earth sniper.
Yeah.
And the pilot could land in the wrong place every time they do it. Because
he's coming down. He's like, well, the runway's right there. He's like, but no, the Earth is spinning. We need to go to the left. Everyone dies.
That's hilarious. So true.